All right, so today I'm going to talk about Haskell, startups, and domain-specific languages. So hi, I'm Adam Wespiser. I started my career off in biology, where I did genomic research for about 5 years, a lot of that using the R statistical language. I kind of had enough of academia and decided to seek greener pastures. So in October of 2015, I went to Boston and found a job with Elon. And that job at Elon allowed me to learn Haskell. So I'm going to talk a little bit about my experience picking up Haskell, using it in industry, and why I think it is so much better than a lot of the other options out there. So yeah, I'm here to talk about using Haskell to build companies. I think that we have 20 years of academic experience with us and an incredible type system. So, yep. To sort of go over my experience, so I really cut my teeth using R. And if you guys are familiar with R, you'll know that, there's some wild things you can do. You can modify the environment, you can use arguments to change the environment. So in order for me to learn R, I really had to think of a lot of program language concepts before I was quite writing programming languages. So it was very beneficial for me, and it also helped that I was writing R for my own consumption, not in production. So yeah, understanding R means knowing that seemingly wacky design decisions were once well thought out. And this is really to the credit of the team at I think it was Bell Labs that wrote the S programming language, John Chambers. They did a really incredible job for what they were trying to do. So yeah, I left grad school and I wanted to do something, work on a company that was using data, machine learning, to build a product, really leverage the advantage of the internet, which is data, and also seek mentors I could learn from. So I knew that walking away from graduate school, I wanted to get involved with something that would take me 5 to 10 years to master. And I think that's going to be Haskell, and I've been going pretty strong since October 2015. So how do you learn Haskell in 5 months? And I think there's one overwhelming idea that's really helped me, and that's ignore the majority of it. So once you focus on what you need to do to get the job done, it's actually not that much material. And then you can, sort of master that and with the base, move on. So for me, it was kind of 2 topics that were really new to me. And one of them is monads and functors, understanding, how these abstractions really power the business logic that we were using. And the second one is type theory, which it's an extremely diverse and rich academic field, but for me came in when I was trying to read code and understand what it did. Like, what do these pragmas do? How is this changing the behavior that I've come to expect? And then finally, there's a really active community. So Twitter, IRC, Reddit, all of those have really helped me find topics to stay motivated. All right, so coming into industry for me was sort of an adjustment. You go from working in a lab where you get the money up front to being in industry where you're working on someone else's time. So what I found a few driving forces in the startup ecosystem. The first of it is information. Like, we truly are in the age of information. We've been here for about 10 years and collected so much data. And the next is this sort of almost desperation that industries have trying to figure out, okay, we've collected all this data, we've paid so much for it, what does it actually mean? And I think this is kind of a lot of the topics that I see startup companies addressing. There's also the cloud. And the cloud gives you an ability to start a company, scale a company with infrastructure that you don't actually own. So it's very easy to go up to scale. Finally, there's 2 things about working in startups that I've come to appreciate. One of them is time. Like, getting things done and getting them done yesterday is an extremely it's extremely important concept because it's not your money, and the people that gave you the money want it back, and you want to help them out. And the final one is that if your company has a product, you are a product engineer, meaning that you need to think, is what I'm doing helping the product? Is all this stuff going into something that's going to eventually make our company money? So that's this appreciation that I didn't have before I started at Elson. So I'd like to really make the point that you can use Haskell for a startup. Everything we know on type theory, abstraction is there, and finally the production libraries are getting up to par that for many cases I would say it's probably your best choice. So the things about Haskell that I've noticed have really made a difference are obviously the type system. I only understand a small part of it, but I would say that if you get something to compile, it's probably going to run. So pragmatically, it gives you this ability and reliability in production and at scale. The next is the production libraries are there, right? Servant, Conduit, Stack, especially Stack, I'd say that I really don't remember the Cabal hell. So I've come in after that and have found that, Stack does what you need it to do, and the deployment stuff is not that difficult. Or if not, Michael worries about that.
We had Cabal hell for a while, it sucks.
Yeah. And then finally, the next concept is expressiveness, and meaning the functional programming thing. And what that really, for me, translates into is that I can take an idea and express it very quickly. There's a lot of mathematical aspects to Haskell, which are, it just creates an incredibly powerful syntax and semantics for describing computational ideas, right? So why hasn't Haskell taken over the world? A couple reasons. One of them is that it's hard to learn. It takes someone that loves doing it, or some position where they really need to learn it. The next is that it has a perception that it's just a research language, and I would say that yes, it is a research language, but it's also a production language, and that research aspect of it makes it by far one of the best production languages. Finally, there's this fear about not finding good candidates, or that if you do something in Haskell, you won't be able to find someone to replace the programmer that left. I think that this is only going to change during the future. And the final one is that Haskell doesn't have, this idea that Haskell doesn't have a library for what you need it for. I think of all the reasons, this is probably the most legitimate. That's kind of too bad. There's some topics like data science and statistics where Haskell doesn't quite have the mind share compared to R or Python. And it's too bad, but I think that it only gives us opportunity to improve that. And so what does Elson get out of Haskell? Well, we get a lot of things, and one of them is that we get a great system to power our backend API and a domain-specific language. The next is that we have really incredibly reliable deployments, and we can deploy front-end, back-end test servers in about 5 minutes. And the final one is that we don't write tests all the time. It's just we get a lot out of the test system there. And so how does Elson use Haskell? Well, this is our basic technology stack. We have our website written in Node.js, and that's going to send back requests, either a simulation or some sort of data exploration stuff, handled by the Scotty server, and then it gets passed into Warp. Warp uses the Alex Happy Lexer parser, then it translates it to an AST, and then that AST is moved into a eval value, which is basically a reader-writer state monad value. We'll grab the data we need in Postgres simple, transform it, and then we'll use ASON to pack it up in a nice package, a JSON package, and then send it back out to the front end. So what really enables us to use a domain-specific language are these monadic interpreters. So it's a very nice abstraction. I know it goes back to the early 90s. You can find this entering the literature, and it gives you a sort of a basic call stack global and local context, the ability for resource management, and it gives you a way to handle database interactions. So what does this look like? Well, the eval, the RWS Monad basically has your, the one we use has a transformed reader, state transform, and resource T transform on the I/O. So the resource monad basically takes care of our database connection. The state monad is just handling the stack, and then the resource T makes sure that we use the I/O in a safe and sane manner. So you can see, right? So we have Yep. So this is basically our eval state, right? So we have the global context, the stack, push pop frames as we move functions or call functions, and then the eval context with our Postgres connection there. So this is really kind of cool, and as somebody sort of new to Haskell, it's almost amazing that this is your language here, the abstraction that describes most dynamic languages. All right, so what are the design goals for Warp? Well, Elson's in the business of helping people in finance better understand their data. At the end of the day, we need to basically wrap all these database calls and allow our users to learn more about the stock market. So specifically, we want a language where a user can say, hey, give me IBM's close price over, the average close price for the S&P 500. So the language has to be expressive. You have to be able to, dice up data, average things, take running means, stuff like that. And then the next is informative, and what that really means is that you have the data in the system that will actually inform the user, and then you can deliver that in a way that the user understands and the user can learn quickly. And finally, there's accurate, which basically means you need to be right. Like if you're in the business of statistical computing, wrong answers are absolutely unacceptable. So this is sort of the accuracy burden is what I personally spend a lot of time on. And I think one of the most important things for me, at least coming out of academia, is that you can't be wrong. All right, so what does Warp look like? Well, the language is called Warp, and it's basically, it looks like JavaScript. So this is like our calculation of returns, right? So we have we can check the types coming in. We don't have a way to enforce types on the return. So yeah, it's basically, pretty easy syntax. All right, so thinking of this, how do we want to design a system that allows users to explore data? And there's a couple of different solutions out there. The first two of these, SQL and SQL OLAP, are, it's a standard like select, group by. SQL OLAP is pretty interesting with this concept of a cube, giving you like a multi-dimensional way to kind of look at data, slice things. This is a very good, I think the only database vendor with this right now is Oracle. But this is some kind of cutting edge stuff. The next is like the split, apply, combine. So you're able to take multi-dimensional data, group on some vector or some feature and then apply a function based on that grouping. So that's one option for us. This is sort of what I've been used to using. Finally, some other data analysis approaches are APL, which is this really cool language that uses symbols to kind of do all this computing stuff. And that's one option that we thought of was, well, why don't we just make a million symbols to handle all of this? Finally, you can do most data analysis with just mutable multi-dimensional arrays. So if you could set the values and let the user sort of create variables, that would probably take you pretty far. And the final one, which is for me something that I've always been interested in, is using the geometric algebra operators, like inner outer products for yeah. So that's, I don't know if there's a good Haskell library to do that, but I would be interested if somebody
There's some stuff in my algebra package for doing geometric co-algebra.
Co-algebra, okay.
We can explain the difference later.
Okay, thank you. All right, so all these solutions are huge, they're big libraries, they're general purpose, but as I said in a slide earlier, we need to build a product and we need to do it now. So what we really need at Elson is a solution that we can get done that is minimally sufficient to enable our users to explore the data. So let's try to find a simpler abstraction. So if you look at this domain, we basically have, so the structure of it is we have instruments, stocks, right? Time series, days and values, and finally collections of instruments along with time series. So that's sort of like what our data is, and for functionality we just need basic operations over stocks, time series, and universes, transformations like take the mean or add a number to a time series, aggregations, which is like say find the average S&P value on it for all days, and then group by filtering stuff, and then finally statistics for time series analysis. So these statistics actually can get pretty complicated. So we have stuff like simple moving averages, but this, if you have ever looked at financial analysis, this topic actually goes pretty deep. So the first thing we need to do, or the easiest way for me to understand the domain-specific language, is looking at the implementation of value. So again, this value is what the eval monad returns. And looking at it, we basically define a value as being, right, so these are our primitive values, and then finally we have time series value, which this time series is a wrapped map. So it's a map of days and some polymorphic value. This is usually going to be a float. It's almost never not a float. And then we have our universe object, which is a map of these equity values, which is right here, and then values. So we've decided to use maps for this. And one of the main advantages of using maps is that we get a pre-sorted structure with I think log n lookups. So it's very efficient and it's very flexible. However, we do pay a price in terms of performance. So this is something that we've had to weigh very carefully and decided to go with because of all the upfront features it gives us. All right, so given our data structures, we're ready to implement some operations. So the sort of data transformation stuff I've been working on has, consisted of these activities, and the first one is to extend primitive operators. What do we get out of making things like time series and universes first-class objects in the language? The second one is implementing some primitive functions in our DSL that allow us to really explore these objects and that can kind of serve as a library of basic functions for further exploration. And then finally, I'll show you some of the aggregation functions that we've been working on. And yeah, so in terms of extending the primitive operators, what you'll notice in languages like Python is that you can do things like string 2 plus string 2 equals string 22, or int2 plus int2 equals 4. And that, this works for a couple different things, and how does that actually work? Well, you have your numeric operators, so this operator will actually go into the primitive environment as a value. It will be called with 2 arguments, binary arguments, and then those will be matched to each of these, like integers will do one thing, floats will do another thing. And then finally, what we have is the vectorized version of this. And what this vectorization allows us to do is combine either lists together with this zip width function, this is the, I think the prelude zip width function. Add the universes together using this intersection with map. So that's only going to take the resulting universe will only consist of stocks that are in both. And finally, we have this is from our own library, which is a zip width function for time series. So it basically gives you a really good source of primitive operations like plus, minus, times, exponentiation, logarithmic stuff. Yeah, and it's very easy for the users to use, and it's, yeah.
I'm sorry, I'm confused by the type of that first guide. Is it for all A?
Yeah, so this is basically saying that for some operator, like the plus operator, so this would be your plus operator, all right, A to A to A. What I think I left out the for all restriction, so normally, so I know for the numeric one we had to add in the num class and the ordinal class to actually get this to work.
Okay.
Yep.
Do you have a typo in the second last line? You have zip width F. That's OPE, right?
Oh yeah, this is, yeah, I've made some changes to this, but yeah, thank you. Alright. Alright, so extending primitives. So this strategy of extending primitives, I mean, it works pretty well, but what we quickly found out is that it has ambiguity in n dimensions, meaning that if you have a three-dimensional structure and you want to reduce it, there's a couple different ways to do that. So basically, if you have like airplanes, people, and puzzle pieces, if you reduce out on airplanes, you'll have people and puzzle pieces, and you can also reduce out on people and have airplanes and puzzle pieces. So this is basically instruments, stocks, and values. So if you want to do aggregation, say get the mean on every day for the S&P 500, that could either be a time series of days and values, which are the means, or it could be for each stock, what is the mean over all days. So this sort of is somewhat of a complication, but this is sort of, the maximum complication we have for this. So we decided to build fold R and map as built-in functions, and then use these for describing our aggregations. So this is our implementation of map. We basically go value, value, and then this one's an eval value, and for storing it as a primitive function, it will be in an eval value. So we basically use map m, and then this eval callable will take a function which is considered a value, and then it makes an array of these position args. So in this case, since it's a map, it's only going to take one argument, and that argument will be turned into an array. So this singleton is actually implemented as a pure from the applicative functors. So then, yep, we do that, and then bind this make list, or for time series, we basically do the same strategy, except we compose return with our time series constructor. Universe is relatively the same thing. So this is pretty simple, and it gives us an ability to iterate over the data structures. And for this case, if you were taking a map or our universe structure, this would give you values for each instrument. Alright, so then the next one is kind of cool, and this is our fold R implementation. And basically, what we've done, I mean, this is kind of a classic fold R, right? So we've defined it as such that the base case, right, so if it's just an empty list, you return Z. If it's a value with a tail, we run the tail first, which is kind of, I guess, a little counterintuitive, because you wouldn't, at least I don't think that. So we recurse on the fold R for the list, and then we will essentially evaluate a callable function using that position argument thing again, and using the applicative into X and run tail. So it's basically, we get a nice fold R here for reducing structures, and then it's implemented for our time series and for our universe objects in relatively the same way by creating a list and then calling itself. Alright, yep, so going again into aggregation. So we start off with this universe, and we either aggregate on stocks to get a time series, or we aggregate on days to get another universe. Alright, so for our DSL syntax, what we have is that map function here, and it's just kind of aliased into two different helper functions. We have each and then over. And then this aggregation by date is going to, it's going to reduce the dates. So in the case of a universe, we have this kind of dynamic dispatch type thing, which is funny because we use Haskell for its great type safety, and then here we've written a DSL that doesn't have that same guarantee. Thought that was funny. But anyway, we start with our base. We use each, which will essentially preserve instruments, and then for each instrument we'll run whatever aggregation function like mean. So the result of this will be instruments and means. Finally, we have our, so if it's not a universe, we just call the function on the base, and the function should be defined with a base case such that it will aggregate for whatever the first thing is. Let's see. Yeah, whatever the first key value that it sees. Then we, how did that happen? And then we have our next function, which is aggregate instrument, which is, we'll just call the function with the base. So with mean, it will, let's see, so this will just aggregate over the instruments, and then just give you days and values. And then, right, we just aliased ag as well. All right, so aggregation works now. So that was pretty cool. And yeah, so that's a lot of the stuff that I've been using lately. And I think for me the kind of take-home message is that, one, it is possible to use Haskell in industry. I wasn't really sure about that until I started. I think comparing how we use Haskell in our development process to other folks I've talked to, I think we have a huge benefit out of using Haskell. And I think that the first source of that is the type system. We get an incredibly powerful tool for offloading some of the some of the mental burden we have. So instead of having to do testing, which is extremely time consuming, and having to constantly be thinking about, oh, will the return value work with what I'm trying to do? If we express it using the type system, which has been, I'm not going to say it was easy, but I'm going to say that it's very helpful. The next thing is that Haskell is incredibly efficient for business logic. And what I sort of mean by that is that it takes few programmers not a lot of time to do a lot of work. So you really do have an economic advantage to using a system that is highly expressive. And the final thing is that I really think the library support gives you the ability to cover most tasks. Like if you're using Haskell for basic web server API stuff, database connections, a little bit of business logic, maybe not that intense stuff in terms of like data science or analysis, it has everything you need, and it really excels at that. So yeah, I'm happy. I'm glad I learned Haskell. So, all right, yeah. So that's basically what I had. So I'd like to thank you all for coming, and if there's any questions, I will be more than happy to answer them. Yeah.
I have 2 questions
Yeah.
just about practical production stuff.
Yeah.
First, how do you organize your project in terms of repos? You said you had a node in front of the Haskell stack.
Yeah. So
the Haskell is a web server, and then it has libraries behind that. So how do you split up all that?
yeah, so it was split up into 2 different repos, and we decided to switch it to a monolithic repo. What we've noticed was that it was hard to get the front end team and the back end team on the same page, and that iteration cycle could be a lot faster if we were using a monolithic repository. I should say our team is about, I think there's like 3-4 Haskell programmers, maybe like 3 full-time, and then there's 2 or 3 JavaScript guys. So it's not, we're not running into the upper limits of manageable GitHub repository, and we are getting a big advantage by, being able to work with branches, split off a branch, front end, back end contributions, and then deploy it to our build farm, and then we can go on the website, click on all this stuff, and test it out pretty quickly.
Okay, just one quick follow-up. So what kind of orchestration tools are you using for deployment? Like Ansible or?
So we were using Travis, but we decided to build our own deployment script. Michael actually can answer that probably better.
So we used to have a huge Ansible script that did all of that, and Travis originally would build all the things on it, and then that would run the deployment to AWS. But we were finding that Travis was very slow, and it was not kind of fitting our needs. So our main backend guy wrote our entire build deployment farm in Haskell, and it runs really fast. And so now what happens is that the build farm ends up building everything on there, and then we can test out the branches directly on there. And then when we want to deploy to our master branch, when we do a release, that ends up putting it on the actual server that we need to.
Just copy over binaries?
Basically, and then that sets it all up and it runs it. Whereas the build farm itself has all the different branches, and you can go to those directly through one URL, and then you can go by branch.
So this is a non-open source tool that you built.
Maybe
it's a bit specific to our needs, and that's one of the main problems with that, is that it's explicitly built for us. We're thinking about making a bit more general, but we're not kind of doing that right now. But in the future, it might be a project if we ever get more time, because right now we're a bit pressed trying to get some releases out for Thomson Reuters.
Yeah, I think if you look at the amount of time that went into it, it was a pretty good Haskell programmer took about maybe 60 hours to do it.
He took about a week to finish it up.
So it's about 60 hours.
Yeah.
Yeah, you had a question or?
Yeah. Well, I was just curious how did Elson ended up using Haskell in the first place, and I don't know if you were there for that or.
Yeah, I wasn't really there for that, but it was basically an individual who was, I think, recruited, or somehow during the last round of funding, somebody came on that said, "I'm going to do this in Haskell," and they were allowed to do it. Basically, architecture the system. And by the time I showed up, there was most of the parts were there.
Okay.
So I think a lot of it was, one individual wrote probably 80% of the architecture, and they did that over the course of maybe 8 months, maybe less if you look at the GitHub history.
Okay. What sort of testing do you do, and which libraries do you use?
We don't really do that much in Haskell testing. We do, Michael does kind of some of the Node.js testing, which basically makes sure that our API is giving general responses. But a lot of the testing that I work on is just checking the statistics. Like if you're going to re-implement something like mean or beta, you're going to have to check it with kind of the business logic guys and some of the finance guys. So a lot of it is just manual checking and then hoping it doesn't break in the future.
To further expand upon that, we did set up a Haskell framework. So some of the properties for the map that we've done, it uses quick check in order to test properties. And then there's some unit testing using HUnit. It's all done under the TC framework in order to specifically test specific functions. But that's not as fleshed out as our integration tests, where we use Node.js to actually test the API calls, which are the most important parts, to make sure that what we send in and what we get out are what we expect it to be.
Yeah, so we don't spend our time writing that many tests, but
You don't.
some of the Michael does.
I write a lot of tests.
Yeah, no, thank you. So yeah, I think there's this idea that Haskell doesn't need tests because of its type system. And I'd say that for internal Haskell stuff, that more likely than not tends to be true. What it does need testing for is anytime it talks to anything else, or any sort of integration with a system that doesn't have the same type constraints. So that's right, our API, our database, and a lot of other stuff, so, yeah. Yep.
What was it like coming into this code base that was 80% written by someone else as a new Haskeller?
I think that it was a little overwhelming. So the original architect didn't stay, so they kind of hired me and then left after a short period of time. So I kind of got, in some ways, thrown into the deep end. So I think at first it was a little bit overwhelming, and then I sort of accepted it. And I would say it's a huge advantage for me learning Haskell because I knew what I was going to need to learn. Like, it was all in the code base. So I think in the end it sort of guided my education. Yeah.
So given that this is exactly the thing that we always hear people fearing will happen if they ever put Haskell to work in the workplace, how long did it take you to get up to speed?
I was contributing, and I think I implemented a feature like in a week.
Okay.
We kind of hacked together what we needed to do, and we were able to hire another developer, I think in 4 days, 5 days. We found the people are out there. So that was kind of really good for.
I just wanted that recorded so I can reference it.
They're out there.
Great.
All right, so thank you.
Thank you.